Hello. So this is going to be an introduction to Rhino.Inside Revit using version 1. I had recorded a similar video a couple years ago when it was still in beta, a beta version, and so at the time I'd mentioned that things were changing rapidly and the video would probably be out of date pretty soon, and so I'm back to record a new one with version 1, and it'll largely be the same tutorial for the most part, but I'll be pointing out some of the new features along the way as I go. So yeah, so we'll just kind of jump right in. I guess, well, before we jump right in, I'll just show the where to find things for getting started with Rhino Inside. You can find on the website here, with McNeil's website, kind of getting started. Here's the download. You'll need Rhino 7 and one of the, Revit version 2018.2 or later, to be working with this. And so yeah, this is a really great resource for just getting a quick overview of everything. And so I'm gonna go through some of these things, but a lot of these things I'm obviously not gonna have time to touch on when trying to keep this video short. So I'd recommend these. There's also some really great guides that go a little bit deeper dive into the different topics, and some of these you'll find actually there will be, either tools that haven't been released yet that you can actually download as like a user object and place into the folder, um, or maybe they're things that maybe they're things that only a few people need, and so they decided not to make it into a tool or something like that. But you can download some of these things that you might need for a particular use case. And then there's all sorts of stuff here for finding other tutorials in the forum and all that good stuff. So just wanted to quickly show that before jumping in. So yeah. So once we have the Rhino Inside open, I've already kind of opened it just to save a little bit of time, but when you first go into Revit to open it, you'll click on here to start it, and then these other buttons will be enabled. And so you can either kind of open Grasshopper directly, and you don't really need to be running kind of the full Rhino window in the background. But if you're like baking things or referencing something that might be in Rhino, then you'll probably want your Rhino window open as well. So in this example, I've already just made a really kind of dumb little squiggly polyline just to show as a starter. So how you could begin to bring Rhino geometry into Grasshopper and then into Revit. So I'll be kind of going through a couple quick exercises. So the first one will be, just very in brief intro to, getting something from scratch from Rhino into Revit. Then look at, referencing a piece of Revit geometry to build some new geometry using the tools. And then we'll do a little bit more of an advanced exercise with some adaptive components and whatnot. So I'll be kind of going through these exercises pretty quickly. So yeah, so let's just jump into it. All right, so I'm just going to reference this Rhino curve and use this to make a wall as the first exercise. So I'm going to set one curve, pick it. All right, so I got my curve, and then a lot of times you'll kind of find yourself working backwards when you're working in Rhino Inside. So you think, all right, I need to make a wall. What do I need to make that wall? So as far as where you find things, you're going to find all your kind of primitives, your Revit primitives in the params tab. So you'll see things like graphical element and grids and levels, and we'll touch upon some of these things in just a little bit. And then in your Revit tab, you're going to find all the other stuff. And there's tons of stuff that has been added since the last time I did this tutorial. So we're definitely only going to scratch the surface during this video, but it'll hopefully, be a good introduction. So with that said, like I was saying, we're going to kind of work backwards a little bit. So if I know I want to make a wall, there's this add wall by curve component here. And so I can see here some of the inputs that it's expecting: a curve, a type, a level, a height. Some of these things they'll make assumptions for us. some of these things we need to feed it. So at the bare minimum, we know we're going to need to feed it a curve. So I'll feed it this curve here. Now what's going to happen is it turned red. So we see here that it's actually expecting a horizontal line, arc, ellipse, or curve. In this case, we have a polyline curve in Rhino. So what we need to do is actually explode this into different segments, and then it will feed it the segments to make it happy. So now we have that curve, and if we look, and I always recommend doing this with two screens. This is always a tough tutorial to do on one screen, but I'll do my best here. So now with just the curve alone, it made some assumptions for us. So it made an assumption for a basic wall, generic 8-inch, unconstrained height of 20 feet. The top constraint is unconnected, so we might want to change some of these things. If we zoom in, we'll actually notice the walls aren't, joining the way we probably would want. So let's kind of go and fix some of these things. So the first thing, it's assuming the base constraint is level 1, which is correct, but just to show if we wanted this wall to be hosted on a different level, we can use the levels picker. And so that could be found in the inputs. So if you go here under inputs, you can find the levels picker. So one of the new things in version 1 that's really nice is that it has, and we'll see. Right now we only have 2 levels in the project, so this isn't the best case of where this would be useful. We'll see it in just a bit where this is more useful. But this new picker kind of gives you the ability to search. So if I wanted to search for, level 1, I can do that. Obviously, it's not the best example here, but so yeah, so this is a nice new feature for version 1, where you can, it's like a picker with a search built in. All right, so we can host it to level 1, and then if we wanted to specify a new type, there's a couple different ways in which we can do that. I'll just do the element type picker for now, and it's going to ask us for a family name here. So for walls, the families it's a system family, so it's usually just basic wall. Will give you most of your walls. And then it'll give you a drop down of all the different wall types that you have. So if we wanted to change that to like a 5-inch wall, we can now plug in the wall type there. Some of these things, if you right click, there'll be some different options for how they display. By default, this one's a drop down list. You can do it as like a checklist. The drop down is obviously nice because it saves space, but some of the other ones might be nice if you're like changing things up frequently and you want to see all your options without scrolling through the drop down. And so now we can, if we wanted to, we can specify a height, or the other thing we can do here is if you right click on some of these, it'll allow you to set the Booleans in this case. So allow joins as a Boolean, either true or false. So if we say true, now those corners look a bit nicer since we allowed joins on those walls. If we needed to flip it, we could. If we wanted to assign a structural usage, we could do that here without having to put in a specific input. So there's good things to know about as you're working. You can kind of like zoom in and right click on some of these things. So as you're working, another common thing after you create an element, so now we've created this element, these wall elements in Revit, we might want to change some properties. So let's say instead of the wall being top constraint of unconnected, we actually want that top constraint to be level 2. So we can, if you do the set parameter, it's actually called just element parameter. There's another nice update that they made in version 1 where rather than a separate set and get parameter component, they're the same component, and you can use that to either set or get a parameter value. So if we just say top constraint here, if I was using this as just a I just wanted to get the value, I can see what that is here. So I have those 4 walls, and there's no top constraint. So if I want to set that top constraint to say level 2, I'm going to just copy and paste this level picker, and I'm going to pick level 2, and I'll set that value. So now you'll notice those walls got a little bit shorter, and so if I click on this now, it says the top constraint is level 2. So that's how you can begin to, a lot of times if you're instantiating some piece of geometry, you instantiate it and then you update some of the parameters. So that's the very basic bare bones kind of example of walking through those steps. So let's take a look at something a little bit more advanced slightly. So a lot of times when we are working with Rhino inside Revit, at least for me, there's usually some sort of piece of geometry or something that I'm referencing inside of Revit, and then building something that kind of reacts to that, or taking that, deconstructing it, manipulating it somehow, and then building geometry off of that, rather than just what we were just doing, where I was just kind of drawing a line in space and creating something. So let's take, for example, an example of how you might use this in practice is, let's say an architect sends a model to an engineer, to a structural engineer, and it has some roof planes in it, and you want to, parametrically design the roof and place a bunch of beams on that roof plane. That would be an example of a good use case for Rhino Inside. So let's do that. And the example I'm going to do is probably something you can do without Rhino Inside. You can have beams hosted to a roof face or something like that, but you get the idea. That as we're going, you'll kind of begin to hopefully see the potential for things like this. So let's go ahead, and the first thing we're going to want to do is reference the roof. So if we come back to our primitives, there's a couple options here. There is a roof element sort of primitive, so we can use that. Also, when in doubt, if you're not sure what Revit category your element might fall into, you can always use like the graphic element, and that's kind of a catch-all for any element in Revit, more or less. So this is a roof that exists in our project, and so we can, if you right-click on this, you can set multiple roofs or set one roof. If you have linked models into your project, it'll also allow you to select elements inside of a linked model, which is really nice. Particularly if, in that example, if I'm the structural engineer and I'm getting a model from the architect, that might be linked into my model, and so I can select geometry from the linked model. In this case, I don't have anything linked in this example, so I'm just going to set the roof that I have here. And so now I have that roof set. And so now I can begin to query this geometry, break it down, and do something with it. So the way in which you can begin to do that frequently, at least the way I do it, is using the element geometry component. So this guy right here. So if you feed in some elements into here, and also you have an option to feed it a detail level. I generally find that for most of what I do, I don't need to specify. Usually, I think it probably defaults to like the course or whatever you have in your view potentially. But just be aware that you could specify that if you wanted to, if you had something where the geometry changes based on the detail level. But just for the sake of speed, we're not going to do that right now. And in this particular example, it wouldn't matter whether it was higher or coarse. So this is our geometry, and it's going to give us a boundary representation, close BREP, of that. And so now I can, let's say, for example, I'm going to create some beams that run, along that slope, and I want to grab like this bottom edge here and this top edge here and make, divide those edges and draw some lines and place some beams. So, a very, very basic example. But again, I'm just trying to keep this, like a bite-sized video, hopefully. And so I'm going to keep it simple for now. All right, so let's deconstruct the BREP, just using the out-of-the-box deconstruct BREP. And so the way I'm going to grab the edges that I want is so we're going to get, 12 or so edges out of here. So I'm going to do the list item, and I'll explain in a bit why I'm doing it this way. But let's say this is my list of edges, and I need to figure out which edge I want. I might just come here, and I'm going to try to visualize this. Let me just hide the preview of this. And so if I click on here, I'm going to jump through here until I see the edge that I want. So I want that edge. So this is like the bottom edge there. And then I'm going to want one more on the bottom part of the roof. So, and the reason I'm doing it this way is that when I change the roof, assuming I'm not adding more edges, like I'm keeping it a rectangle for now. So, which is a large assumption in reality, but for our purposes, we'll work with it. So if I change this roof, if I move it, the order of those edges is likely to still stay the same, and so that's why I'm kind of doing it this way. There are other ways in which if this piece of geometry is more likely to change throughout the life of a project or something, you might want a more intelligent way to pick those edges or something. So let's roll with this though for now. So now we have our two edges. We're just going to divide the curves using the out-of-the-box divide curve. And I'll say, let's do 20 beams. Seems reasonable. And I'll just copy and paste this and feed it this curve. And so now I have my start and end points for the beams. So I'll just do a line by points. And I'll do this. And so now I have my curves, which are going to be my, my location lines for the beams that I'm about to instantiate using the Rhino.Inside Revit tool. So up to this point, like all this is just out of the box Grasshopper stuff. But now we're going to start getting back into the Rhino.Inside Revit tool. So one of the things we can do here, again, I'm kind of jumping to the end of what I need, which is a beam, and then I'll work backwards a little bit. So I need a curve, a type, and a level to build a beam. So a little bit simpler than a wall that had a bunch of other options here. So we have our curves, which is just going to be these lines here. And then we need to feed it a type. And if I, let's see, I'm going to use this same, we're going to look at a few other ways in which to grab types, but for this bit of the exercise, I'm just going to use this same element type picker. Instead of basic walls, I'm going to look at, I think it's called W shapes. Yep, so W shapes is the sort of out-of-the-box Revit family name for W shape structural framing. And out of the box, it kind of comes with this 12 by 26 beam. So I'll use that as my type for now. Obviously, you can import if I want a different size, I could import a new shape and use a different section for the beam. I'm just going to leave it for now. And then my levels, let's say I'm just going to copy and paste from what I had up here. And let's say I'll leave it as level 2. And so now I can begin to see my beams both. I can preview it both in Rhino or in Revit. So now those beams exist as elements in Revit. You'll notice that by default it's going to pin everything. So if I wanted to make this in Revit and then manually manipulate it, I would just need to unpin it. Alternatively, there's like an unpin, you can like unpin all, I think. Let's see, unpin, it exists somewhere. Um, or pin, I think pin element. Okay, yeah. So pin element allows you to specify a Boolean, whether true or false. So if I wanted to unpin everything, I can feed it here and then tell it false. Um, I generally I leave it pinned until I really need to unpin it. So I'm just gonna delete that for now. Now, one thing you'll notice by default is that the beams are kind of set up that they are in the Z justification as the origin, when really you want it to be the top. So at least most of the time, you would want kind of the top of that beam to align with the bottom of the roof or the bottom of the floor slab or whatever you're kind of working with. So I am going to change that using the element parameter tool that we were just looking at before. If I can spell element parameter beam, so that'll be our element. The parameter is going to be Z justification, and then our value. So the values were like a drop down. It's like origin, top, bottom, or whatever. So it's actually not gonna like it if I just said, top, because it's not really a text field. It's gonna throw an error if I try to do this. It's really kind of an enumeration. I won't really go too much into the details, but basically I can feed it 0. There's 4 options. I can feed it either 0, 1, 2, or 3. In this case, I think 0 is top. You can always kind of just do a trial and error, but if we, let's say, if I recompute this, let's see, okay, so now those beams appear at the right, so now they're top justified. So we can tell, those curves, just to explain that for a second, those curves are now, at the top of the beam rather than in the center, which is typically what we would want if we're, trying to map some beams to a roof plane. Okay, so that's really all I wanted to do for that, those first couple of quick exercises. I'm going to jump into, we'll kind of look at the lever house example building that we've used in some other projects and look at kind of bringing in some geometry from that. So I'm going to jump back to Grasshopper and I am going to switch over to another file here. Now another thing that's kind of new to Rhino.Inside is document-aware components. So certain components, if you zoom in onto them, we'll be able to. So if we, let's just look at that wall thing we were looking at before. If you zoom in really close, you'll see this little thing here that says insert parameter, and it'll automatically insert the document. So by default, whenever you kind of open Grasshopper, whatever document you had open here is going to be the active document. Now it kind of gives you the ability to specify which document if you have multiple documents open. I would generally, if you can avoid it, just work with one Revit document at a time. It's going to keep things a lot simpler. But if I was kind of curious as to now that I have 2 documents on, if I'm curious as to which one this Grasshopper file is currently looking at, I can, query what the active document is, and so I can see that this is now looking at this lever house Revit file. So that's the one that I want to be working in, so that's good. But that's just kind of like a gut check, as if you're working with multiple Revit files. If something seems off, you're not seeing what you're expecting, you might need to check what your active document is. And I think basically the way it would work is like whenever I start like a new Grasshopper file, it's going to do a check to see what file is currently active, and that's what it's going to default to. All right, so let's look at just some examples of baking in some geometry from our Revit model into Rhino. So this is a case where, let's say we have a pretty well developed Revit model and we just want to bring some stuff into Rhino and begin messing with it, or bring it into Grasshopper and begin messing with it. So we can look at some of the built-in categories. So let's say I wanted to bring in all the floors, for example. So I'm going to use this built-in categories picker, and again, this is a better example of why the newer version has this really nice kind of search ability. I'm going to switch this over to the layout, or let's see. So you can switch it to list or details. I'm going to switch it over to list, and I'm going to search here for floors. Okay, and now I can click on that. So you can see why that search is really nice now, because we have a lot of stuff in here, and so we can easily kind of get to what we want using the search functionality. I think it's still selected. I can double check that here. Okay, Revit category floors. Good. So now we can use something like there are what are called filters that allow you to filter out certain things. So we want the category filter in this case. So I'm going to feed it the floor, and this is going to spit out the element category filter object, which we're then going to use to query some elements. So we're going to query elements, and this is going to be our filter. And this is just going to query everything like in the active document. So this is how we would ask Revit, the Revit document, what are all the floors? And this is again a new thing I believe with Rhino.Inside version 1 is there's this limit of elements that it'll give you by default. So we don't have more than 100 floor elements, so it's not an issue in this case. But if you have more than 100 of an element, you might need to kind of remove this just by zooming in and clicking that little minus sign, or you might want to manually kind of like make the limit larger or something like that. All right, so now that we have our floors, we can do what we did before where we were getting the element geometry. So we can grab our elements, and so now if we were to look in Rhino here, so now all of our floors came in here, and we can, if we wanted to, we can bake it just using the old-fashioned, right-click bake and then tell it what layer. And then if I wanted to come in, I can say layer 1, and I can come into Rhino and say change this, change the name of this layer to floors. So we can do it that way. And if you're just doing like a few things, it's probably the simplest way to do it. If we wanted to be a little bit fancier and kind of automate some of this stuff, there's also, we can get the category name by using the category identity tool here, and we'll grab the category again, and then we can, if we looked at the name, so this is just to get the name, so we're going to use that to make the level name. And then there's some different plugins that'll allow for this. I think there's one called Object Bake, which I guess is in Lunchbox. So this is a separate plugin. So if you don't have Lunchbox, you're not going to see this. But again, this is really, you don't need this to, do what I'm doing. You could just right-click and bake it to whatever layer you want. This is just to automate some of this. If I wanted to say the layer, I'm going to create a layer called floors, and then give it the geometry, and then I'll just need a Boolean toggle, and I can then set that to true. And so now that probably what happened was, I probably should have deleted the previous version. So let me undo this. If I were to rename this, I don't know, floors X, just to, I guess, avoid confusion. So now if I redo this, it'll create a new layer called floors and put those elements on there. So these two components, again, is just like a fancy way. If you're doing this for a lot of different Revit categories or something like that, you can do it that way too. Okay, so keep moving along. Another, just to kind of, let's collect, if you wanted to collect some walls, for example, let's just copy and paste this, and we'll search for walls. I'll check that. And so now I have the Revit category walls here. And so now what we can do is there's a few options. Let's say I wanted only to get a certain type of wall. So let's take a look here. Let's say I only wanted to get the exterior metal panels on the metal panels on metal stud wall here. So I'll come back to Grasshopper and the element type picker that we were using before. We can actually, it's a little bit unintuitive, but you could plug something into here. And I don't know why it gave us that error, but let's just keep going. It seems like it's still allowing us to go forward. What did I say it was? The metal panel. Where are you? Metal panel, metal stud. Okay, so, and then similar to how we had a filter before, now we would make a type filter. Feed in that type, and then we can query the document. I'll just copy and paste from here. Actually, let me copy and paste all of this, both of these things. And I'll feed that filter in. So this will grab all of that specific floor type. So rather than bring all, or wall type rather. So rather than bring in all of the walls in the model, let's say I just wanted those wall types into my Rhino model or my Grasshopper model, I can just grab those wall types. And then if I wanted to, push this into Rhino, I could just bake it. Okay, so that's kind of what I wanted to go through for grabbing and bringing stuff in from Revit to Rhino. The last thing I want to show is using the adaptive component tool to kind of do something a little bit more fun. All right, so previously and I go through this in some of the other tutorials, but I'm gonna assume that you know what adaptive components are in Revit, and they're basically these components that you place by points. I've pre-baked, just for the sake of speed, I've pre-baked some things in here, so we can just walk through these rather quickly. But basically, kind of building out based on the geometry that I brought in from Revit, I kind of built out I have these curves, and let me just preview some of this stuff so we can see it real quick. So I had these curves that I built, and then I lofted them, and I broke them out into surfaces just using the domain, divide domain, and the isotrim, and then I got so this is going to give me the vertices, which I'll feed these vertices into eventually the adaptive component, which is going to want a list of 4 points for the adaptive component that I have in the Revit model. And then we'll come back to this part in a second. But basically, just wanted to save a little bit of time in the video, so I pre-built some things in here. So we have these panels, and then in Revit I have an adaptive component. It's called adaptive panel 1B, and all this is if I were to place this in the model, it's kind of asking for 4 corner points, and it's this like little cone And if I were to click on it to see what properties it has, you'll see that there's, an aperture size, a panel depth, um, and some like a rotation angle. So there's some different parameters here that I could begin to play with. So if I wanted this aperture size to be bigger, I can make that like an 8-foot aperture size. So this is just a kind of a somewhat simple adaptive component that we're going to use to like panelize this curvy facade, which would be something that would be a little bit tricky to do directly in Revit. It's definitely possible to do, but if you wanted to really customize it and begin to use some analysis tools that are available in Grasshopper and things like that, it's nice to be able to use Rhino and Grasshopper rather than be limited to the tools within Revit. Okay, so with that said, let's jump into the adaptive component. So the adaptive component, where are you? Add adaptive component up here. So it wants points. So I have my points here, so that's good. And then it wants a type. So I need to grab a type. So another way for generic models, another way to grab types is I can say, query types, and then I can feed it a family name. So adaptive panel 1B. I'm showing just a few different, there's a bunch of different ways in which you can grab like types and things like that. So there's no right or wrong. I'm just trying to show a few different ways that you can do it. So that's actually both in my case, the family name and the type name. So I'm just going to do the type name. And if I were to just put a generic picker on here, that will allow me to pick the adaptive panel. And I can now use that as my type. And then my vertices are my points. And it's now going to, place whatever. There's probably like 100 or so panels that it's going through and placing now in Revit. So this will take, this could take a minute if you have a lot. If you're doing like a lot of panels, it might take a while. So you see now I have all those panels that were placed, and they're actually, now I need to go and do that step where I'm kind of, maybe I need to flip these. If I click on one of them, you'll see that it has like this flip, which is expecting a Boolean, and by default it's not flipped, so maybe I want to flip them so that they're sticking out instead of in. And then let's say I also might want to change, one of the parameters of the opening or the rotation or something like that. So I'll quickly kind of go through and do that. All right, so let's do that. So what I've set up here is basically kind of saying as you go up the building, so I'm grabbing the centroid of each of those. Let's open Rhino here so we can see. So I'm grabbing like the centroid of all of those panels, and I'm grabbing the Z value, and then I'm just kind of mapping that domain of I'm getting the min and max bounds of those Z values, and then I've manually said I want, an aperture size between 1/2 foot and 8 feet. And so I'm now remapping the kind of bounds, which was 30, a Z of like 34 feet to a Z of 302 feet roughly. I'm mapping that bounds to between these two numbers. And this way it'll give me like a reasonable panel size. So if I look at the mapped values here, and you'll notice that I've grafted this. I'll show you why I do that. Let's look at a panel here. So our vertices, or actually rather, let's just look at the components themselves. Are in a they're grafted, so they're each in their own list. So when I go to edit the parameters here, I want to make sure that the so I'll use the element parameter again. So this is my element. So the values, the sort of, this gets into data trees a little bit and list management, but basically this list needs to look the same as this because we want a unique value for each panel. So we've grafted this here, and now I'm going to just set the parameter value. Let's see, what did I call it? Aperture size. So I'll come back here, and I'll say aperture size and then I'll feed it these values, and it'll think for a second because now it's going through and adjusting those whatever 100 plus panels. And then the last thing I actually also wanted to do was flip them. So we'll say flip. I'm just gonna, just to be safe, I'm gonna disable this as I'm kind of reconnecting things. Flip, and I'll set that value to a Boolean, which will be true. And let's try this. So now it's going to go through and flip all those panels, hopefully. Okay, so now we see those panels are flipped, and we see that the aperture size is increasing as the panel kind of Z value increases. So that was just kind of a random, somewhat random way to, show variation in the panel. And so now we can, begin to manipulate this as, as the building changes. We can go back and change our geometry. Actually, the other thing I didn't show when we were in here was if I come back, and now I need to switch back over to this file. If this roof geometry changes, the beams will update with it. So that's kind of, I forgot to show that, but that is one of the big sort of points that you want to make with Rhino.Inside is that the whole idea is that it's parametric. So in this case, we were referencing some curves that we had built in Rhino, but you could, have those based on some sort of parameters that exist in the model as well, and have it be a little bit more parametric. So that is about all I wanted to show. I know it was a little bit longer than I intended it to be. It's a little bit longer than most of the other videos, but hopefully that, kind of gives you a good introduction to the Rhino.Inside Revit tool. Thanks for watching.